Hello, everybody. So today we're going to talk about lesson 11.2. We're on page 469 of the 5th grade Go Math textbook. And our essential question is, how can you classify triangles? And you'll recall from earlier grades that we can name a triangle based on the measurement of its sides as well as the measurement of its angles. So this is kind of basically a review of earlier grades. So let's look at the unlock the problem. If you look closely at Epcot Center's Spaceship Earth building in Orlando, Florida, you may see a pattern of triangles. The triangle outlined in the pattern at the right has 3 congruent sides and 3 acute angles. What type of triangle is outlined? Okay, so we see the blue triangle outlined here. Okay, so let's look at classifying the triangle by the lengths of its sides. So recall that if all the sides are equal, we call that an equilateral triangle. If 2 of the sides are congruent and the third side isn't, we call that an isosceles triangle. So there are 2 congruent sides in an isosceles triangle. And in a scalene triangle, we'll notice that none of the sides are congruent. They all have different measures. So we would say 0. So that's the 3 different ways we can measure by name by the sides. Now on this angles, if a triangle has one right angle, we call that a right triangle. Okay, you can't have more than one right triangle in a right angle in a triangle. In an acute triangle, you'll notice that all the sides are less than 90. Angles that are less than 90 degrees, we call those acute angles. So an acute triangle has to have 3 angles less than 90. And if it's an obtuse triangle, it will have one angle that is greater than 90, but less than 180. So obtuse triangles have one obtuse angle. So what type of triangle is outlined in the pattern? If we look at the sides, all the sides are equal, okay? And we can confirm that by measuring. So I see that it's 15 millimeters along the base, 15 millimeters along this side, and 15 millimeters along that side. So it's an equilateral triangle. And the measurement based on its angles, okay, I don't really need to use a protractor for this because I noticed that all the sides, all the angles are less than 90 degrees. Okay, so that would be an acute triangle. So the triangle as outlined is an equilateral acute triangle. All right, let's go to look at page 470. All right, for page 470, you'll need a centimeter ruler and a protractor. And we're going to classify triangle ABC. Okay. So measure the sides of the triangle using a centimeter ruler. And then label each side with its length. All right, so A to B is 40 millimeters. Or you could say 4 centimeters. B to C, or side BC, we'll call 30 millimeters. And side AC is 60 millimeters. So none of the sides are congruent. And if we do use marks, we would say 1, 2, we have 3 different sides. So just based on its sides, I would call that a scalene triangle. Now we need to measure the angles of the triangle. All right, so let's measure angle A. Get your protractor, line up one of the sides with 0, and see where it crosses the other side. So this one is about 26, 27 maybe. Let's see. If we were to extend that out, (26 degrees). Okay, angle C. And that out. Looks like it crosses about 36 degrees. Okay, so that would be a 62-degree angle. And B looks like it's greater than a 90-degree angle, but let's confirm that. Okay, so this is going to be my 0 line, so I'm going to use the inside numbers, and it crosses, looks like at about 120. So I'm about 2 degrees off, but the key point here is that there is an obtuse angle. Okay, I might have these each off by like 1. This is probably 25 and 35. Okay, because triangle has to add up to 180 degrees. So this triangle is a scalene obtuse triangle. Scalene because all 3 sides are different. Obtuse because there's one angle greater than 90 and less than 180. All right, so now we're going to practice drawing our own triangles. And so the first one we have to draw is a scalene acute. So that means all 3 sides are different and all 3 angles are less than 90 degrees. Okay, so let's start with a basic, a line that will be the base. Okay. All right, and I'm going to make this first angle 35 degrees. I'm going to have all the angles be different sizes. So I'm going to line this up with 0 mark and find 35. Okay. All right, so this is 35. And my next one, I want to make it 65 degrees. All right, so I'm going to go up to here. I'm going to measure from the other side this time. From the other side. Okay. And I'm going to find 65 degrees. Okay, so I want the angle to open this way, so I'm going to use the outside marks, and I'm going to find 65. Okay. I'm going to connect it. Okay. So if we've done this correctly, we have 65 and 35. That's 100 degrees. So this should be an 80-degree angle. So we're going to line it up with 0. See where this line crosses, and it looks like it crosses right at 80. All right, so now right now we know that this is an acute triangle because all the angles are less than 90. So that part of our triangle is accurate. Now we have to confirm that all three sides are different lengths. So let's look here and go from 0. Let's put points in A, B, C. Okay, so the length of AB is 45 millimeters. The measurement of line AC is 50 millimeters. And the measure of line BC is 30 millimeters. So none of the sides are equal and none of the angles are greater than 90. So we have an scalene acute triangle. All right, in our next one, we're going to draw an isosceles acute triangle. All right, on this one, I'm going to start with two 50-degree angles. Okay, so I'm going to draw my line for my base. Okay, I'm going to choose one side to be the 0 side. I'm going to find 0. I'm going to have it open this way. So I'm going to use the inside marks. I'm going to find 50. And I'm going to draw a dot. I'm going to connect it to the base. Okay. Then I'm going to go to the opposite side and have it open this way to 50 degrees. Connect them. So this should be an 80-degree angle because they have to add up to 180. So just confirm it. If this is the 0 side, it crosses at 80. Okay. You can erase the excess line. Okay, so right now, I know that those two are equivalent. They're 50-degree, or I'm sorry, we're drawing an acute triangle, so all three angles are less than 90, and we want two of the sides to have the same measure. So again, let's go A, B, C. The measure of angle A, the line AB mm, 29, maybe 30 millimeters. AC is 35 millimeters. And line BC is 29 millimeters. So these two sides are congruent. The third side is not. So isosceles and acute because all three angles are less than 90 degrees. All right, obtuse triangles. Scalene obtuse. So here we don't want, we want one of the angles to be greater than a 90-degree angle. And so on that, we can go ahead and draw our line for the base. And we know that this time the angle is going to be, one of the angles has to be greater than 90. So that right there, I know it has to be less or greater than a 90-degree angle. So there's my obtuse angle. Now, I know I don't want any of the sides to be equal. So right now, this one is measuring 40 millimeters. Okay. How long is this side right now? Well, I can make it just 20. I can call that 20 millimeters. And then how long would it be to connect the other side? Okay. So here's our obtuse angle. Two of the sides are not equivalent right now. And the length of the third side, line AC, is about 53 millimeters. So we notice that none of the sides are equivalent. So we've drawn a scalene obtuse triangle, scalene obtuse. And finally, we're going to draw an isosceles obtuse triangle. Okay, so that one, let's see, I'm going to make it 30 degrees that way. 30 millimeters that way. And I want an angle that's going to be greater than 90 degrees. I'm just going to make it also 30 millimeters. Okay. So this side is 30 millimeters. This side is 30 millimeters. So I know that that's going to be isosceles. And if I connect the sides, it looks like the third side is going to be 55 millimeters. So that is isosceles. And this angle here would be my obtuse angle. Okay. All right. So let's move on. Number 1, page 471. Classify each triangle, write isosceles, scalene, or equilateral. Then write acute, obtuse, or right. All right, well, first thing I notice is that all three sides are different. So I know it has to be scalene. And then the measurement of the angles, that's less than 90, 90, less than 90. So acute. All right, number 2. Now I don't see any marks. I don't see any measurements, but I do see congruent marks. The sides are all equal, so that's going to be an equilateral. And they're also showing me that all three angles are the same, so equilateral, acute. Okay. Number 3, I have two congruent sides. That's what the marks are telling me. So this is isosceles. And if this is 29 degrees and these two angles are the same, so 180 minus 29, because the triangle angles have to add up to 180, I'd get 151 degrees. Well, let's roughly call that 150. What's 150 divided by 2? 75. So it's probably 75 and a half, each of those. Okay, so 151 plus 29. All three angles are less than 90 degrees. So isosceles, acute. Right. A triangle has sides with the lengths and angle measures given. Classify each triangle, write isosceles, scalene, or equilateral, then write obtuse, acute, or right. All right, 3.5, 6 2/10, 3.5. So we have two sides that are equal. So it's isosceles. And we have one angle that's greater than 90, but less than 180. So obtuse. Number 5, none of the sides are equal. So that's scalene. And again, I have one angle that's greater than 90, but less than 180. Obtuse. Okay, number 6, circle the figure that does not belong and explain. Well, I see a right angle in this one, and I see a right angle in that one. So it's this middle shape that doesn't belong, because these two are right triangles. So the middle shape is not a right triangle. All right, number 7. Draw two equilateral triangles that are congruent and share a side. What polygon is formed? All right, well, I know that if I draw three 60-degree angles, that it'll be an equilateral triangle. So 60 and 60. Okay, that share a side. Okay, so I'm trying to figure it out how to make it fit. Okay. All right, so 25 millimeters on each side. If this is my base of 25, I know I need to make another line that's 25. And then 25 to close it. Okay. All right, so we've drawn two equilateral triangles joined together. Okay, they're sharing a side. This side in the middle is being shared. So what polygon is formed? Well, 1, 2, 3, 4. Quadrilateral. And it doesn't have any right angles. Okay. So I could call it a parallelogram. And the question is it a regular polygon? Well, if it's a regular polygon, all four sides will be equal. Okay, well, let's go ahead and put points in. All right, so line CD is about 23 millimeters. Line AB is about 25 millimeters. Line AD is 23 millimeters. And line CB is 25 millimeters. So no, not all sides are equal. So it is not a regular polygon. Okay, it's not a regular polygon. All right, let's look at number 8. I want to make one more note about number 7. Another way that this is not a regular polygon is not all the angles are the same. This is an acute angle. This is an obtuse angle. So there's no way it can be congruent. All right, number 8. Shannon said that a triangle with exactly 2 congruent sides and an obtuse angle is an equilateral obtuse triangle. Describe her error. Well, if it's equilateral, all 3 sides have to be congruent. So also equilateral triangles have 3 acute angles. Okay, so there's no way to draw an equilateral obtuse triangle. All right, number 9. Kelly drew a triangle with exactly 2 congruent sides and 3 acute angles. Which of the following accurately describes a triangle? Well, 2 congruent sides makes that an isosceles triangle. The 3 acute angles makes it acute. So isosceles acute. All right, number forces and balance for numbers 10 and 11. What makes triangles good for the construction of buildings or bridges? The 3 fixed lengths of the sides of a triangle, when joined, can form no other shape. So when pushed, triangles don't bend or break. Okay, they're showing you with a 4-sided figure. You push down on it, they'll bend or break. Okay, but when you push down on a triangle, there is no bend or break. So classify the triangles in the structures below. Write isosceles, scaling, or equilateral. Then write acute, obtuse, or right. All right. So number 10, let's measure the sides. I'm going to call that about 9 millimeters. This side is about 13 millimeters. And the base is also about 13 millimeters. Oh, sorry. I measured the first side wrong. The first side is 10, 11, about 14. All the angles are less than 90 degrees. So this is an isosceles right triangle. So let's confirm that one of these is a right angle. Sorry about that. Okay, so this angle here is lining up exactly at 90. So this is a right angle. Okay, so it has one right angle. 2 of the sides are equivalent, so isosceles right triangle. And number 11, I know it has to be a right angle because this forms a right angle. So I know that that's right. Now we have to measure the sides to see if they're the same measurement. I would call the bottom line about 6 millimeters. Eight millimeters. and 10 millimeters. So scaling. None of the sides were equal. Okay. All right. So in our next lesson, we're going to continue some work with triangles. So until then, I will see you soon.